Welcome back. In the previous video, we were solving equations using multiplication. In that case, we take a look at a couple of examples where we had our variable being multiplied by a fraction. And in that case, we multiplied our fraction by the reciprocal to isolate the variable. Well, division is going to work in a very similar way. In this case, the variable is going to be multiplied by an integer or a whole number. And in that case, we simply just divide our variable and our whole number, by the coefficient. Let's take a look at a few examples of this. Let's say we have 3x equals 6. Okay, so we have our variable being multiplied by 3 here. So the way we undo this or isolate our variable is we divide by 3. Okay, so 3 is going to cancel with 3, and whatever we do on one side, recall we have to do on the other side. This keeps the equality in our equation, so we're going to divide the other side by 3. This is going to cancel right here, leaving just x on the left side. Over here, we just have 6 divided by 3, which is 2. So x equals 2. Okay, let's do a few more of these. Very straightforward. Let's say we have 5x equals 7 over 9. Okay, we have a rational number on this side, but that doesn't matter because we're only concerned with our variable here. We want the variable on one side and all this other mess on the other side. So we have our variable being multiplied by 5, by a whole number. So we're going to divide both sides by 5, which is going to isolate this variable. This is going to cancel here, and we're left with x on the left side and 7 over 9 divided by 5 on the right side. Well, recall 5 is simply 5 over 1, and when we're dividing by a rational number, we simply don't ask why, but we flip the second and multiply. If you need a refresher on this, go back to the video on dividing rational numbers and get a quick practice on that. So we have 7 over 9 times 1 over 5. We flip the second and multiply when we're dividing rational numbers. Now this is pretty straightforward. We can multiply through the top, 7 times 1 is 7, and multiply through the bottom, which 9 times 5 is 45. So 7 over 45 is our answer for x. Remember, we can always plug this value in for our variable in the original equation just to check our answer. Let's take a look at another one. Let's say we have 7y minus 2. Here, our variable is being multiplied by 7, so we can undo this by dividing by 7. Whatever we do on one side, we have to do on the other side. 7 cancels with 7, leaving just y on the left side. And over here, we have a minus 2 over 7. And this won't simplify anymore, so we'll leave that as our answer. Let's say we have a minus 9x equals 3 over 8. Okay, here our variables being multiplied by a negative number. So what we want to do, we actually saw this in solving equations using multiplication, that whenever we have our variable being applied by something that's negative, we want to include the negative sign when we're canceling out the coefficients. So we want to divide here by a negative 9. And we do the same thing on the other side. Negative 9 cancels with negative 9, leaving just a positive x. We don't want a negative x, we want a positive x. Over here we have 3 over 8 divided by minus 9 over 1. We don't ask why, but we flip the second and multiply. So a minus 1 over 9 times a 3 over 8. We're multiplying two rational numbers. A positive and a negative gives us a negative. 3 times 1 is 3. 8 times 9 is 72, and we want to leave it in simplest form. So this will equal minus 1 over 24. We simply pulled out a factor of 3 out of the top and the bottom. Okay, so let's be careful with our signs and make sure that we're solving for a positive x and not a negative x. Actually, let's look at an example of that. A simple example. Let's say we have a minus z equals something. Let's 901.1368. Okay, I'm being facetious on this side, but we want to solve here for a positive z. Now, the cool thing about this is actually already solved for z, but it's solved for the opposite of z. So what we want to do is we want to divide both sides by a -1. When we're dividing by a -1, all we're doing is we're essentially just changing the signs on both sides, because the negative is going to cancel with the negative, just leaving z. And all dividing by a -1 here is going to change the sign of this number. So minus 901.1368. Okay, so we always want to be sure that we're solving for a positive variable. We don't want the opposite of it. Let's do a couple more. Let's say we have a minus 8z equals 0. Okay, so what do we do here? We want to isolate our variable, leaving everything else on the other side. So we want to divide here by a -8. We do the same thing on the right side, just to keep the balance. -8 is going to cancel with -8, leaving just z on one side. Now here we have 0 in the numerator. Now this is simply z equals 0. It's okay to have 0 in the numerator. It's only when we have 0 in the denominator, which is undefined. So 0 in the numerator is just fine. That simply equals 0. But we never want to have 0 in the denominator, because that's undefined. And we'll actually go over that in a later section when we're dealing with linear equations. But for now, let's do a couple more. Let's say we have 4x equals 13. Okay, our variable is being multiplied by a +4, so we're going to undo the multiplication by dividing by a +4. That's going to cancel with that, leaving just x on the left side, and we need to do the same thing on the right side. So our equation is still in balance. We have x equals 13 over 4. 13 over 4 is prime, so it actually won't simplify any further, so that's our answer. Okay, let's do one more. Let's say we have a minus 13z equals a minus 52 over 5. Okay, we want to solve for z, so we divide by minus 13. We'll do the same thing over here, a minus dividing by minus 13. Go ahead and write it as 13 over 1, because we see we're going to have to divide a fraction here. This cancels with this, leaving just z on the left side. We have a minus 52 over 5. We're dividing by a rational number, so we don't ask why, but we flip the second and multiply. So we have a minus 1 over 13. Negative times a negative gives us a positive, so these two cancel out. We have 52 over 5 times 1 over 13, which gives us 52. 52, and 5 times 13 gives us 65. And we can reduce this to 4 over 5. 4 over 5 is our answer. Okay, so we see when we're multiplying by a whole number or an integer, we can simply divide. We can solve the equation using division by dividing by that coefficient, and that isolates our variable x. And we can always leave this to plug in our value for our variable to check our answer. I'll see you in the next video.